Hi everyone. In this video, we will see binary search problem. So we are given an array of integers num, which are in sorted ascending order, and an integer target, and we have to write a function to search target in nums. And if target exists, then we should return its index. Otherwise, we should return -1. And there is this constraint that we must write an algorithm with O of log n time complexity. As you can see in this array, we have to find target as 9, as target is there on at fourth index, hence we return 4. For this array, when we have to find 2, as 2 is not present in this array, hence we return -1. As you know, the sequential search, in our sequential search, we would go checking one by one whether this target is -1, whether it is 9, and basically compare one by one element in this array. But then we have to traverse the entire array, and in this case our time complexity will be O of log our time complexity will be O of n, but we have a constraint that our time complexity should be O of log n, which is better than O of n. So what we can do here is to use binary search algorithm. So in binary search, what we do is we calculate the middle element. So in this case, this will be our left, this will be our right, and hence every time for every iteration we calculate middle element. So currently this is our mid. We basically compare our target with mid element. If that if that target is equal to mid element, then we return the index at mid element. If our target is greater than our mid element, that means that that target might be present in the right half. Otherwise, it must be present in the left half if basically target is less than our mid element. So in this case, as our 9 is greater than 3, that's the reason we should not care about this left half, and we should only care about this right half, and hence we move this low pointer to mid plus 1, and then basically again recalculate the mid element and continue in this half, and go by dividing the array by half size each time, and hence overall time complexity of this algorithm is O of log n. So if we see the source code, we have been given the nums array and the target. So we initialize our left index at 0, our right index as nums dot length -1, and then while left is less than or equal to right, so while these two index do not cross each other, for this condition, basically we calculate the mid element. So as you might have seen in the multiple implementations, that mid is equal to left plus right upon 2, but actually that might cause overflow error, and that's why actually we should always have mid equal to left plus into the brackets right minus left upon 2. So this does not cause overflow error, and always calculates mid correctly. So once we calculate the mid, we should check whether the target is present at the middle index of this nums array. If the target is present at this index, then we return the mid index. Otherwise, we check whether whether target is greater than our nums, the element at our middle index. If target is greater than our element at the middle index, that means that we should move this left pointer to this mid plus 1, so that we only restart our search in the right half. Otherwise we shift our right to mid -1, and we continue our search only in left. Once we come out of this loop, this will happen when left's value becomes greater than right, and at this point basically we there is nothing more to search, and we come out of this algorithm and return -1 in this case, saying that the target element is not present in our nums array. Just one thing to keep in mind while applying this binary search algorithm is that for this, every time when you want to discard half of your array from the search space, we have to make sure that the given array is in sorted order, sorted ascending order.